So we have an athlete here who wants to do her workout every day doing jogging and cycling. But she also wants a life, so she wants to minimize the number of hours that she does every day just to stay in shape. So we're going to let X be the number of hours a day that she spends jogging, and Y be the number of hours she spends a day cycling. And what she wants to minimize is the number of hours that she spends, total number of hours, which would be X plus Y. So we set up our little grid here. X is the number of hours a day she jogs, Y is the number of hours a day cycles, and she has two constraints here. The aerobic points, she wants to make sure she gets enough aerobics points. So for jogging, she gets 12 aerobic points for every hour she jogs, and 9 aerobic points for every hour that she cycles. And then she has another constraint of miles that she has, and she wants that to be at least greater than or equal to 36, but we'll get to that later. And then for miles, for each hour that she jogs, she covers 6 miles, and for each hour that she cycles, she covers 18 miles. So then you just fill in X, X, Y, Y, and you want the aerobics points to be greater than or equal to 36 points, and the number of miles, she wants to cover at least 54 miles a day. But then she has an added constraint that we didn't really put in our grid here, that she wants the number of hours that she spent cycling to be greater than or equal to the number of hours that she jogs. So these are our 3 constraints here, and we're going to simplify them now. You'll notice 3 goes into each number here. 3 into 12, 4, 3 into 9, 3, 3 into 36, 12. So we get this as our simplified constraint. Here 6 goes into everything. 1, 3, and 9. So 1x, 3y equals greater than or equal to 9. And then what we do for here, we just bring the x to the other side and make that minus x plus y greater than or equal to 0. Then we make the graph. Here, when x is 0, y would be 3 into 12, 4, so we have 0, 4 here. And when y is 0, 4 into 12 is 3, so it crosses at 3, 0, and that's our line, and we label it 4x plus 3y equals 12 lines. Here, when x is 0, 3 into 9 is 3, so 0, 3, 1, 2, 3. And when y is 0, x would be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3, 0, 3, 9, 0. And then we label our line x plus 3y equals 9. Now this one, minus x plus y equals 0, goes to the origin. So 0, 0 is 1 point, but then you just have to find another point that gives you 0. I use 3, 3. Minus 3 plus 3 is 0. So 1, 2, 3, 1, 2, 3 would be this point right here. It would cross. I'll just kind of make a little break there. So it goes from 0, 0 to 3, 3, and it would be this line here, minus x plus y equals 0. Now, you'll notice it has to be above these 2 lines and to the left of this line. So basically, you don't cross over any lines. And a minimum program is always up. You're seeking to go as low as possible for a minimum program. So you've got 3 corner points, 0, 4, and you have this corner point here and this corner point here that you have to find. So you look to see which lines is this corner point. It would be 4x plus 3y equals 12. I put it up here. And the other line is x plus 3y equals 9. It would be this one here. Now, when you subtract the two equations, you get 3x equals 3, and then substitute in, and you get x equals 1. So your corner point would be 1, 8/3, which is what I have here. So 0, 4 so far, and 1, 8/3. Now, for this corner point, it would be this line here, minus x plus y equals 0, which I have over here. And the other line is x plus 3y equals 9, which I have here. Now, when you add those two equations, the x's drop out, and you have 4y equals 9, or y would equal 2 1/4, 2.25 if you prefer, or 2 1/4. And then x has to equal y, so it would be 2 1/4, 2 1/4. So those are your three corner points, and you line them up. Then you put your objective function. What is it you're trying to minimize? The number of hours, x plus y. So substitute 0 for x, 4 for y, and that would be the value of your objective function for that corner point. 1 for x, 2 2² for y. So 1 plus 2 2/3 would be 3 2/3 for the number of hours. Here, x would be 2 1/4 plus y 2 1/4 would be 4 1/2. Then you look to see which one gives the minimum number of hours, and it would be this one here. So you'd write out your final answer that she should jog 1 hour a day, cycle 2 2/3 hours a day for a minimum number of this many hours, and that would satisfy her constraints here.